Okay, we're going to talk about subtracting polynomials that do not have common denominators. So we're going to talk about how to get them and then how to handle the subtraction. And so first of all, I'd like you to take you back to some other things you already know. Way back when you learned how to subtract integers, so like 3 minus a negative 2, you're probably taught something that was called change, or add the opposite, where you change it to addition and then change the sign of the second number. So this becomes 3 plus positive 2, which then gives you 5 as an answer. Same kind of thing happened when you went into the section on polynomials, where they said take this set and subtract this set. They said change it, add the opposite, change it to addition, and then change the sign of the second set. So it becomes this, because essentially what you're doing is you're taking a -1 times each of these things, and that's what you get. So then that's what you're going to combine with this. And so this would be a negative x to the third plus 6x minus 5 would be the answer. And then if you see this, you see a subtract and then this whole set, again, you can turn it to add the opposite. And the thought is going to be that this is really a -1 next to this. So -1 times just what was on top. So this means change the sign of everything on top. So you get -3x minus 1. And the denominator stays the same. So that's the kind of stuff I wanted to lead into what we're going to do next. Now here, the common denominator, first you want to make sure that you factor everything so you can see what the ingredients are to each of the denominators. And in this case, you can't factor it. It's already in factored form. So then the next case is make sure that both must have the same thing. And you're going to give it stuff. You're not going to take away. You're going to only give to make them have the same stuff. So if this has an x plus 7, this also needs to have an x plus 7. So I'm going to give this an x plus 7 here, and make sure you do it to the top, and it's multiplying. And then this needs to have the same stuff that has. So we're going to give this a 5x minus 7, and make sure you do the same thing to the top. So now that we have the same denominator, we're going to clean up the top part because we know the bottom has to be 5x minus 7 and x plus 7. But the top part, to clean it up, we're going to have to distribute it. So we get 18x plus whatever 7 times 18 is. Let's see, 6, 5, 126. And then this, be careful here. This is a -7 times 5x and -7. So it's going to be a -35x plus 49. And so we're going to need to then put -35x together with 18x. And that gives you -17x. And then 49 with the 126. Let's see, that's 15, 7. So that's 175. And this, we want to check it in our answer. We want to factor it also to see if we can reduce it, but this can't be factored. I don't believe. Yeah, 17 doesn't go into 175. So this is the answer for that one. So let's come down here to the next one. Again, step 1, factor everything. So this is going to be 5x over, let's see, 4 and 1. It's going to be -4 and -1. Subtract, and then we already have the top part factored. That you don't necessarily have to do that. We're going to actually unfactor it. We're going to multiply in a second. But the bottom we need to have factored. So what makes 8? 4 times 2, so it'll be -4, and x plus 2. Okay, so now we have this factored. That's the first step. Next, we want to make sure that both sides have the same stuff. Like they both already have an x minus 4. That's good. This one doesn't have the x minus 1 that this one has. So let's make sure it has the x minus 1 here. Do it on top and bottom. Now these are almost alike, but this one doesn't have the x plus 2. So we'll give this one x plus 2. Okay, so we can see now that the common denominator is x minus 4, x minus 1, x plus 2, because that's what they both have. So we're going to clean up the top. We need to distribute this. We're not doing that to the bottom, but we're going to do it to the top. So we get 5x squared plus 10x for this one. And here we have negative 3 times just these two. Not everything, just these two. So we get negative 3x minus 6, and it's that whole thing times x minus 1, so we're going to have to FOIL this. So we get negative 3x squared, and, oops, is that minus 6? Or that's minus 6. I thought it was said plus. And so first outer would be plus 3x, and inner would be minus 6x. And then the last would be plus 6. So now we need to put all this stuff together. This is all of our top stuff here. So we got 5x squared and negative 3x squared. It gives me 2x squared. And then I have a positive 10x, and a positive, that's 13x minus 6x is 7x. So we have positive 7x. And then we have a plus 6. That's the top part now. We know the bottom part is that common denominator that we said earlier. Now, here's where we want to go ahead and see what we can do to factor our answer to see if it can be reduced. So 2x squared plus 7x plus 6, we're going to multiply the first and last, list the factors, put the signs on that according to whatever the middle term is goes on the largest one, and then they had to multiply in this case to make a positive 12. So now I know everything's positive. So the set that made the middle term is 7. We can't put that right into sets. We're going to rewrite this so we can do factor by grouping. 3x plus 4x plus 6. So we used this set to rewrite this. And now we factor out what's common. And here, pull out what's common and what's left. Okay, so one set says 2x plus 3. The other says x plus 2. So we'll come back up here and put that with, bring down that denominator of x minus 4, x minus 1, x plus 2. And then we can remove sets that are alike. So then our answer is what's left over, 2x plus 3 over x minus 4, x minus 1. That was a long one. There you go.